A single pulse of light, invisible until it's too late. Satellites go blind, sensors die, GPS stutters, and whole militaries lose sight of the battlefield. This is the dark promise of high-power laser ASATs, weapons that disable satellites with beams of concentrated energy. No debris field, no dramatic explosion, just a blackout from orbit. How the threat looks on paper. Anti-satellite ASAT weapons used to mean missiles smashing into hardware and spraying deadly debris across orbit. That's noisy, traceable, and politically radioactive. Directed energy ASATs are different. They aim to blind or burn out sensors, fry electronics, or heat critical components until the satellite fails. Delivered from high-power ground lasers, sea-based arrays, or potentially from space platforms themselves, these systems promise surgical, deniable effects, at least compared with kinetic strikes. What the tech is actually doing today. Multiple countries and private groups are pushing directed energy research hard. Ground-based high-energy laser HEL systems have demonstrated point defense against missiles and drones. Scale that up, focus on exo-atmospheric tracking, and the same physics enables attacks on low Earth orbit optics. Recent tests and reporting show nations experimenting with space-trackable laser arrays, and classified programs are rumored to have performed non-kinetic disabling tests on imaging payloads. The move from line-of-sight air defenses to counter-space missions is a short conceptual jump, and operators are already thinking in that space. Why lasers are tempting for counter-space ops? Lasers are nearly instantaneous, scalable by power, and leave little physical trace. A ground laser can dazzle an imaging sensor from hundreds of kilometers away, degrading ISR intelligence, surveillance, reconnaissance capability for minutes to hours. A more powerful shot can permanently damage optics or electronics. For commanders wanting to blind an adversary's eyes in a theater, satellite imagery, missile warning, navigation, a laser offers an attractive option. Rapid, reversible in some modes, dazzling, irreversible in others, sensor burnout, and politically murky compared with a missile that sprays debris for decades. Limits, countermeasures, and the physics reality check. Atmosphere is not a friendly medium for orbital strikes. Turbulence, weather, and atmospheric absorption scatter beams and diminish power over range. Which is why ground lasers must be massive and highly adaptive, using adaptive optics and precise tracking. Space-based laser platforms sidestep weather but add enormous complexity and cost. Satellites can harden optics, add shutters, or maneuver to reduce exposure. And unlike a missile, laser effects can often be observed and attributed, which reduces the illusion of plausible deniability. Strategic risk. Escalation without a smoking crater. The strategic danger isn't only technical laser. ASATs create a new kind of ambiguity. A blackout can look like cyber sabotage or system failure, and attribution delays risk misreadings. Worse, a campaign of satellite blinding erodes command, navigation, and early warning networks rapidly, compressing decision cycles and increasing the chance of miscalculation. The temptation to use non-kinetic means to avoid immediate visible escalation could paradoxically make crises more fragile. Why this matters now? Space is no longer peaceful. Commercial constellations, national security satellites, and critical civil infrastructure all ride in low orbit. As laser power grows and tracking improves, the toolbox for taking these systems dark becomes real. Whether deployed from deserts, ships, or the heavens themselves, directed energy. ASATs shift the geometry of modern conflict. Control the skies and you control much of the fight below. The next blackout may not come with a bang. It may arrive as a whisper of light that stops a camera, kills a sensor, and obscures whole battlefields. That silent power, and the politics it unleashes, is the next frontier of warfare.